Hello, my name is Kareem Zaid. I study electrical engineering at the Lassonde School of Engineering, and I've taken biomedical devices due to the importance of engineering application in the medical field and how this knowledge can be used for analyzing and resolving health issues. I've learned how to develop the fundamental hardware and the design of a biomedical device and how to apply it in the real world of medicine.
My name is Ryan Caraba, and the topic of the course, EECS4641, is Introduction to Medical Devices. Throughout the course, I've learned the key importance of the most common medical devices such as ECG, EEG, ELG, and EMG. I've learned that all medical devices process signals received from the body in similar ways. In the beginning of the class, we created a circuit for ECG measurements that was composed of a square wave oscillator, an instrumentation amplifier, high-pass filter, low-pass filter, band reject, and band-pass filter. We then proceeded to learn how to design these filters for the outputs desired. Overall, the course gave me interest to learn more about the medical field.
Hello, my name is Richard Lee. I'm a 4-year student of electrical engineer at York University. This video I'm going to talk about the project I'm doing for course EECS4641, which is a medical device course. In this course, we study how to process continuous signal from a human body.
This project is entirely based around electromyography, which is the study of electrical activity produced by the muscles. The more muscle activity your muscles produce leads to larger electrical activity received. The electrical activity produced can be seen in the form of electrical signals with amplitude as a function of time. The main goal of this project is to choose a specific muscle group, and in our case, we chose the lower back. The next step is to record electromyography signals corresponding to specific movements that can be distinguished from one another by a program we will create. We chose to take 4 different movements, which were leaning forward, leaning backwards, leaning left, and leaning right. Once we completed taking the data and obtained all 4 base signals from the BioPAC system that was provided for us, it was time to start distinguishing the signals from one another. This began with us exporting the signals into MATLAB for ease of signal processing, where the program was created. The function of the program will take the original EMG signal movement recorded from the BioPAC, and based on the specific movement that was made during that time period, our program will output the corresponding movement received. The creation of the program will be explained soon by Richard.
Here we have a diagram of the back, which was crucial towards finding the most ideal placements of electrodes so the BioPAC signals had large amplitude. The red points on the back indicate the positive electrodes placed on the thoracolumbar fascia, and the white points indicate the negative electrodes placed on the external abdominal obliques. Lastly, the black points indicate the ground reference node. For all the movements as we move out of the upright position, the amplitude of the signal captured in the BioPAC system increases, and once back to upright position, the amplitude is flatlined. Each movement was carried out 5 times during recording to ensure the data was accurate. Richard will now be talking about the next steps of processing the signals.
Here as we can see, this is the raw data collect from the BioPAC. It have a lot of noise. We have to filter out the noise, and then we apply the filter to signal. We centerize the signal, and then we turn the EMG to integral signal. This is the signal after process. We clearly can see fine movement here. After split fine movement up, we store it to a library sample. Any other signal new record, we can compare with the library, and from there we know which movement of a human body is making. Here is the demonstration. Now we're gonna load the data to the software. This is the data. Now we're going to detect this data is according to the left movement. Let's detect the body bend to the left. Now we're going to load the data for the back. This is the data for the back. This can detect the data for the back. Now let's do the data for the right. And we detect correctly.
The most interesting thing about the final project was being able to extend all our basic knowledge learned about EMG throughout the semester to a specific muscle group, which for us was the lower back.
Providing a way of analyzing the back will help prevent long-term difficulties such as arthritis, before it reaches a severe stage.